I also have to tell you that I love these problems. They're my favorite. Um, I don't love teaching them necessarily because they are kind of difficult to help with whenever you get stuck, but I love doing these problems because whenever you do these problems, it looks like crazy stuff, and then like if you finally see the answer, you get to the point and like, oh, you know what to do, and it just all comes together there at the end. The other reason I love these problems is because unlike what you were doing last night, every single one of these problems already has the answer with it, and that's always a good thing if you've got the answer key to check it by, right? When you are verifying trig identities, you must simplify in order to show that both sides of the equal sign are the same. And you may not move anything from one side to the other. So I'm going to give you a second to copy. I would probably write this down, and I would probably make that bold right there because you are going to make sure you don't try to do that. And then here's our first example you can copy down as well. Line down through my equal sign, and you cannot move anything from one side to the other. You can work on both sides of the problem, although for this one there's not much you can do to sine x, so it wouldn't make much sense to do that. But you are going to work on one side or the other. You can't like subtract sine cubed x from both sides. So you're not moving anything from one side to the other of the equation here. You're just trying to prove that these two sides are equal. So pretty much what it is like last night's homework would have just looked like sine cubed x plus sine x cosine squared x. That'd be all that you'd see, and it'd say simplify. Well, tonight's homework is going to look like this, and you're going to have to simplify this so it equals sine x, so it gives you the answer that you're going to have. So that's always good to have the answer. It also means sometimes you can get by with faking it, but since I am, of course, checking to see that you know how to simplify this, and I already gave you the answer, I'm not looking to see that you get sine x. I'm looking at your work to see if it is correct. So whenever I grade these, and you definitely can't get by with this, so, well, I'm going to do this in my head, sine x equals sine x. Okay? You cannot do these in your head. What you're doing here is you're showing me how one side equals the other. So I have to follow your work every step. You can't skip steps on this because your work is proving that these are true. And, oh, I did it in my head does not count. Because if it did, then you get every single one of them right. Although it does mean that you can fake it if you don't know how to do it a little bit, and you might get at least some points because the answer has to be sine x. So make sure at the end, even if you don't know how, at the end you've got sine x equals sine x. Even if you just made it up, right? Sometimes it might work out for you. Most of the time you might get some points for knowing how to do some of it, but you're not going to get all the way there if you didn't really know how to do it. For example 1, I've got sine cubed x plus sine x cosine squared x. I see that I have a sine x in both of these terms. So what I can do here is I can factor out a sine x. And if I factor out sine x, then if I take a sine x out of this one, I'm going to have sine squared x. And if I take a sine x out of the second term, this sine x right here is just gone completely, which just leaves me cosine squared x. So I'm just factoring out a greatest common factor. And then as you get to know your trig identities more, you should see like light bulbs going off everywhere. What is it, Patrick? Sin x squared x plus cosine squared x is 1. I do want you to show me where you replace that. So sin x times 1. And then so that, of course, equals sin x. And we're just going to bring this side down, sin x. So we can show both sides equal sin x. On some problems, it's more important than others that you replace this with a 1. But it's probably just best not to skip that step. I would let it slide on this problem. But if you did not put that step where you said times 1, but there's somewhere it's going to be important that you put that step. Okay, questions? Sin x equals sin x. We got this one right here. So, next problem. Oh, wait, no. Strategies to try. I'm not going to take the time for you to write all of these down here because that might take a little while. So some things that can help you here. Transform the most complicated side first. On the last problem, it was pretty clear which side needed some work and the other one was just going to stay the same. But it's usually a good strategy to start with the most complicated side first. You're going to substitute basic trig identities whenever you see them. So when you see sin squared x plus cosine squared x, put 1 there. If you see like tangent, sine over cosine, you can replace it with tangent. Factoring sometimes is helpful. So on this past problem, we just factored out a greatest common factor. But sometimes factoring doesn't do you good. Sometimes it might be helpful to multiply things together. You can see where this is starting to get a little more difficult because I can't tell you always do this step on each problem. You have a bunch of strategies that you can try. Sometimes you may need to get like denominators and add together. Sometimes it might be helpful to change everything to sine and cosine. We saw that on the homework when we were looking at it. Is there one more? It might go to the next page. Yep. There we go. And these are not the only things you can try, but these are all strategies that might be helpful. If you didn't have time to get all these, I'll post these on Canvas so you can look at those. And as we do more and more of them, they'll just become things that you do. All right, so here is our next example. Cotangent theta equals cosecant theta over secant theta. Alright, so, I can't factor, I can't multiply, because there's nothing to factor or multiply here. I can't replace with trig identities, really. Well, I guess I could in a way, but not anything like sine squared plus cosine squared, not our Pythagorean identities. So, a good strategy on this might be to change everything to sine and cosine. You can either work on one side or you could work on both sides. It really doesn't matter. I think I'm going to work on both sides just to show you that you can. Cotangent of theta. What is it it is cosine of theta over sine of theta. And at this point, you might still need to sort of have your list of identities nearby so you can look back at them. But eventually, by Wednesday, we'll have those memorized. Now, cosecant, it is 1 over sine theta. And secant, it is 1 over cosine Now, this over here can't really do anything with. Let's work on this side to see if we can get it to match the other side. So, when I've got 1 over sine theta divided by 1 over cosine theta, dividing fractions is easy as pie. We'll flip the second and multiply. So, we are going to have 1 over sine theta times cosine theta over 1. What do we do to multiply fractions? Straight across. 1 times cosine theta is cosine theta. Sine theta times 1 is sine theta. And look right here. Both sides equal each other. Cosine theta over sine theta. Now, one thing about these problems is you may not do the problem exactly the same as somebody else in the class, but you might both be right. For example, somebody might decide they don't really want to work on both sides of this equation, so they might not do anything to that cotangent theta here. So if you don't do anything to cotangent, your last step here, cosine theta, sine theta, you could just make that cotangent theta, and then just bring this all the way down here, cotangent theta, right? That also would be correct. So you may not end up with that same last line as somebody else, but you could both be correct. You can also be wrong. You can do things that are wrong. Like if you decided to add sine and cosine, like if you put a plus sign in between here, that would not be correct. So you can do things incorrectly if you don't follow the laws of math, but you can do things differently than somebody else and still get it right. All right, here is our next one. Alright, so secant squared theta minus tangent theta cotangent theta equals tangent squared theta. Probably I want to work on the left-hand side first. That would probably be my best bet. If I wanted to, I could work on both sides here. Let's work on the left-hand side. And let's just go everything sine and cosine. Try that, okay? So we'll have 1 over cosine squared theta. And whenever you have squares, it is okay. Like if I have secant squared theta, it is okay to say that's 1 over cosine squared theta. Even though our identity is that secant theta is 1 over cosine theta, even though it's not squared on our identity, it's okay to change that if it's to any power. So if it was to the 3rd, 4th, 5th, we can still do that for this problem. However, like sine squared theta plus cosine squared theta equals 1, that is true. Sine theta plus cosine theta, that does not equal 1. Okay, it's the difference with having that plus sign in there again. So sine squared plus cosine squared, it's got to be squared. If it's not squared, it doesn't equal 1 anymore. But this is legal move right here. And then tangent is sine theta over cosine theta. And cotangent is cosine theta over sine theta. That looks promising right there. Because now, before you cancel, always make sure that it's multiplication in between the two fractions where you're going to cancel. But we have multiplication here. We do have subtraction over here, but we're just working with this term right here. So cosine and cosine can cancel. One's on top, one's on bottom. Sine and sine can cancel. What does that leave us with? It's not going to be 0. It's going to be 1 right there. And that's, a lot of times when we cancel everything out, we don't write anything there because it's all gone. But anything divided by itself, that's what you've got here, sine theta, cosine theta over sine theta, cosine theta. Anything over itself is 1. So you've got to put that 1 there. Okay. So we have a couple options of how to do this problem. And let's just do, I'm going to do what's the quickest here, although there's another way that you eventually would use. So 1 over cosine squared theta, I'm going to write it back as secant. Actually, no. Let's do the longer way. The longer way is probably, it's not easy, but it's probably easier to comprehend than this. Okay, so this is 1 over 1. I cannot subtract those unless they have common denominators. Okay, so to get common denominators here, I would have to multiply this by cosine squared theta on top and bottom. So I would get 1 minus cosine squared theta minus cosine squared theta over cosine squared theta. And I could put those together since they have common denominators. I could write it as 1 minus cosine squared theta over cosine squared theta. Okay, now I'm going to put a side note over here, and I went over this in the video as well, but we'll reiterate it here. I know that sine squared theta plus cosine squared theta equals 1. And this is a side note. I am not doing work on this side right here. So I know that's true. So if I subtract cosine squared theta from both sides, sine squared theta equals 1 minus cosine squared theta. So this right here is technically not a separate identity, and it's not because it's just a rearrangement of the Pythagorean identities. But when it comes to actually doing problems, you need to have this memorized. So when you see right here that you've got 1 minus cosine squared theta, then we could replace that with sine squared theta. Okay, so even though this is not a separate identity, it's just sort of a rearrangement of the Pythagorean identity, we want to know anytime we see 1 minus cosine squared theta what it equals. Same is true if I have sine. It's not, we don't need it for this problem, but if I have sine squared theta plus cosine squared theta equals 1, if I subtract sine squared theta from both sides, cosine squared theta equals 1 minus sine squared theta. So both of these, we don't need this second one for this particular problem, but both of these are rearrangements of the Pythagorean identity, and we need to know them to be successful doing these problems. And so we are almost done for this problem, because what is sine over cosine? Tangent. And sine squared over cosine squared is going to be tangent squared theta. So we could just draw a line down here, tangent squared theta. As you work these problems, I do want you working down, as I'm doing here, instead of across, just because it is much easier for me to follow if you do that. When you go across, and then it's just much easier for me to follow if you do that. And if you go across, you might run the risk of me not following what you've done, and then you won't get credit. Now, notice right here, I kind of went across right here. That's because I ran out of room. If you draw me some arrows because you ran out of room or something on the quiz, that's fine. But try to make it very clear. Either work down, or if you have to go sideways, make it clear what order you went in so I can follow it. Okay, questions? The identities quiz is going to be on Wednesday. That's just memorization. The actual quiz is going to be Thursday, the one where you got to be able to do the problems. So, and we are not doing anything new in between that time. We're just going to do more and more and more practice of this. So hopefully by then we'll be ready for it. We'll have lots of practice. All right. Okay, here's our next one. All right, this particular problem is a good example of one where there's two pretty good ways to solve it. Neither one's really harder than the other. So if I give this to students, a lot of times I'll see half the class do it one way and half the class do it the other, and both are correct, and really both are just as good as the other. I'm actually going to do this problem both ways. So if you follow the advice of the strategies to try, I would tell you to solve the most complicated side first, which I would say is probably the left-hand side, the 7 sin x plus 5 cosine x, because it's got a fraction in it. Although this does have secant and cosecant, whereas this is already sine and cosine. You could go either way. But if you're wanting to simplify the left-hand side, you are going to divide both of these terms. Have I told you guys about the love connection? We've done the love connection. Okay, so the love connection tells us this. Like, let's say I have like 2x to the third plus 4x over 2x. The love this is not directly related to this problem, just to show you how to do love connection. Love connection tells me if I'm dividing by just a single term in that denominator, I could divide this term by 2x, and then I would also have to divide this term by 2x. So, and I call it Mrs. White, that used to be the calculus teacher, she always really talks about the love connection a lot. The love connection is called the love connection because whenever you circle them like this, it makes this cute little heart. And it's adorable. So if you divide 2x to the third over 2x, then you're going to get 1x squared, and if you do 4x divided by 2x, you will get plus 2. Okay, so that's the idea behind the love connection. So if we do the love connection here, we would divide 7x by sine x cosine, or 7 sine x by sine x cosine x. And I'm going to write that out because that's way more complicated than the other stuff. So 7 sine x over sine x cosine x. And then we've got a plus sign here, so we have a plus in between. And then we would divide 5 cosine x by sine x cosine x. So 5 cosine x over sine x cosine x. Okay. Love connection you could actually even add to your list of strategies. It's a good strategy to try. Now, whenever you go to college and you have like super smart college professors that have PhDs in math and are geniuses, maybe don't call this the love connection. That's not proper mathematical terminology, but it helps me remember it. This really doesn't have a special term. You're just dividing both terms by sine x, cosine x. So it's really just dividing. But your professor might think you're crazy if you tell them that you're doing the love connection in math class. It's dividing, but that helps me remember what to do there. And so once you divide, you've got 7 times sine x times cosine. Everything's multiplied here. Now, you do have a plus sign in between the two terms, but we're only worried about canceling over here on the left-hand side, so I could cancel a sine x, and that would give me 7 over cosine x. Now, I am canceling. There is a plus sign, but the plus sign's not between the things I'm canceling, so this is okay. And then over here, 5 times cosine x sine x times cosine x. Got cosine x on top and bottom, multiplication in between, and so this gives me 5 over sine x. Now we're practically to the answer here, because 1 over cosine x equals secant x, right? Well, you do not have to write this next step. I'm going to just write it. So I could write it like this: 7 times 1 over cosine x, and 5 times 1 over sine x. You do not have to write that step. It's okay with me if you skip it, because if you have a cosine x in the bottom of a fraction, you can just move it up to the top and make it secant. And if you have a sine x in the bottom, you can move it up to the top and make it cosecant. So this is going to give you, let me erase this other stuff down here. This is going to give you 7 secant x plus 5 cosecant x, and you can see that matches the other side. Okay, questions? How are we doing on time? All right, I'm going to do this the other way real quick. So I'm gonna erase this stuff. Oh, it doesn't let me erase it on this. So I can show you the other way to do this problem real quick. I'm gonna go through a little faster. All right. So you could choose to only work on the right-hand side instead. So you could make this 7 times 1 over cosine x and 5 times 1 over sine x. Again, you don't necessarily have to write that step. You could write it like this: 7 over cosine x plus 5 over sine x. It is okay with me if you just move those to the bottom. You don't have to write this step. This right here is optional. Just trying to be abundantly clear of what we're doing here. And if I want to add those together, what do I have to have first before I can add fractions? Common denominators. So to get common denominators for this one, I would need to take this fraction and multiply it by sine x on top and bottom. And I would take this fraction and I'd multiply it by cosine x on top and bottom. And look what happens whenever I do that. I get 7 sine x plus 5 cosine x all over sine x times cosine x. And that is the other side. So really, some of you might find that way easier to understand than the other, or some of you might prefer the other way. But you could solve this either way and it would be correct. Okay, questions? All right. Oh, wait. This is our last one. Sine A over cosecant A plus cosine A over secant A equals 1. Now, if I had to pick a favorite strategy, I would probably say it's changing everything to sine and cosine. I find that to be one that we use more often than the others. So I'm going to do that here. I'm going to change everything to sine and cosine. So this numerator just says sine A. But the denominator is 1 over sine A. And over here, numerator is cosine A, denominator is 1 over cosine A. And then if you ever end up with complex fractions, right, like we've got here, fractions inside of fractions, you want to get rid of those as quickly as possible because they will give you trouble. So dividing fractions is easy as pie. Flip the second and multiply. So we've got sine of A times sine A over 1 plus cosine of A times cosine A over 1. At this point, you might even be starting to see what's going to happen. And light bulbs come on, choirs of angels start singing. And sine A times sine A is going to be sine squared A. And cosine A times cosine A is cosine squared A. And then sine squared A plus cosine squared A just equals 1. So we can bring this on down. Okay, questions? All right, so your assignment, let me make sure this is the correct page here. 434. Yes. We're going to do, actually, I'm going to, I think there's one we don't want to do. No, I think we can do these. I don't think this one has. So 13 through 26, all is going to be your homework. Some of these are going to be really quick, that only has like 1 or 2 steps and you're done. Some of these are going to be a little more extensive. My instructions are the same as last night. Make sure on every single problem you try something. Now, you might change everything to sine and cosine and then have no clue what to do and leave it there. That will be acceptable on your homework. I mean, I would rather you, of course, get the answer, but it is acceptable to do just like one step and get stuck. But you must try something on every problem. Okay, questions? All right. So you've got like 15 minutes. You can go ahead and get started on these. Anybody else need a signature for MPAs? Let's see. I need to write down who's not over here so I know. Let's see. Sydney, Emma, Gracie, Evie, did I sign one for you today? And Chase, you have one? Yes. all the juniors would just leave.
No,
For the junior, no, if all the juniors are gone, the seniors are probably go to school and take it easy that day. If you all go on the junior trip. So all the seniors are going to tell you, juniors, please sign up.
but what if not all the juniors go? What if there's like...
It depends on how many go. So like tomorrow we got like 5 missing. Class will go on.
Who's all going to the junior trip? You going with that either?
If you need a signature.
No, it's not. No, it's not. No,
Yeah, it's
all
honestly not.
my classes are juniors. All the juniors go, damn, it don't matter.
I've never been to that Civil Rights Museum. I think that'd be interesting. Yes. Let me. So we're really just doing more practice. Like we're gonna put some of these up on the board.